Welcome to Circuit Talk Funders and Founders. I'm John Cole, Senior Manager on the Semiconductor team at MITRE Engenuity. We are a nonprofit dedicated to solving problems for a safer world. Our semiconductor team is hard at work meeting the nation's challenges around semiconductor breakthrough technologies and the CHIPS Act. Circuit Talk Funders and Founders is part of MITRE's Circuit Talk podcast and video series, and it elevates the revolutionary, disruptive work being done by semiconductor entrepreneurs and investors. This is an exciting time to be working with semiconductor startups. The nation is waking up to just how critical they are to our national and economic security. I'm joined today on Circuit Talk Funders and Founders by Dr. Rahul Sen and Mr. Rob Snowberger. Dr. Sen is a materials engineer who's been working in the semiconductor industry for over 20 years. And Mr. Snowberger is CEO of Nantero and has a background in national security, finance, and building startups around deep technologies. They're both executives at Nantero, a startup founded in 2001 that developed NRAM, which is an ultra high density, ultra fast, ultra low power memory based on carbon nanotubes. Nantero has been a very active member of the Semiconductor Alliance and has helped our team at MITRE Engenuity orient ourselves around semiconductor startups and the startup world, and has contributed a lot to our white papers and our request for information responses. So it's really fun to have you all on the show and to talk about Nantero. So
thank you, John. It's an honor to be here.
Thanks. Well, you all have had quite a journey starting. Nantero's had quite a journey starting up. Can you tell me about how we got to this point and what it's been like?
Yeah, no, absolutely. Thank you for the opportunity. As you mentioned, Nantero is the world leader in carbon nanotube technology. And what does that mean? That effectively means that we are pioneers of a new material in the fab process, in the CMOS process. And while there are some other companies, especially large companies, who have programs or who have had programs, Nantero, as you mentioned, has been at this for 20 years, and we've been doing it as a startup or an SMB, small and medium business. There's not exactly a clear-cut category quite yet, but in any event, we are a small company based out of Woburn, Massachusetts. So that's right outside of Boston. We also have a facility in Sunnyvale, California, Silicon Valley, and we got started in 2001 out of Harvard graduate school program for chemistry, where our carbon nanotube based memory cell was created by our co-founder, Dr. Tom Ruckus. And so from there, the idea was, just like you said, is that we had a technology with a new material that could be as quick and as high performance as DRAM, but yet is non-volatile, meaning we could fit the bill for the fast-paced memory that's required for direct processing computations, but we also could be non-volatile and save a whole bunch of power in your cell phone and your laptop, et cetera. And so over 20 years, you have to think, okay, well, what is that time taken? First of all, these technologies take a long time to progress. You have DRAM, which was invented in 1966. That is our largest competitor, if you will, but it's also a $100 billion a year global market. So it's not exactly a competitor. It is the status quo. And we are trying to figure out a way to offer a better solution. So, as a new materials company, the first step in that process is, hey, can I get this material into a CMOS fab? Will anybody who has these $50 million, $100 million machines let me touch it with this new material, considering how important contamination issues are? And so what our CTO, Dr. Sen, who joins us today, and what our team has perfected really is an aqueous solution that can go into a spin coater and can coat perfectly aligned. Well, Rahul won't allow me to say perfectly aligned. Engineers will not allow that. But for my chair, they're pretty aligned. And so anyway, we can coat a 12-inch wafer in a commercial size. And so when you're in this portion of the business, you have to start there. And that's where we started in Woburn. Woburn is an ISO 9001 facility, chemical facility. From there, once you've created the chemistry and the material, you get your first shot at a fab. Our first major engagement with the fab was with LSI Logic. And moving from there, we've gone into higher commercially focused fabs. And, you can kind of see behind me a little bit about our progression. We have a small kind of researchy wafer there, then you got an 8-inch wafer, and then finally 12-inch. And so that, when you're doing a chemistry that spreads out over a wafer, it's really important that, that material spreads out evenly across. And so all of that is a part of the progression. Now, cyclical industry, fabs are open, fabs have availability, fabs are shut, fabs say, nope, no way, I could make more money printing out, status quo chips and not really looking to do anything new. So over the next, let's say the first 7 years, we're developing the chemical process. The balance of that time was in various fab engagements, advancing the technology. And we're really proud of where we are. We know that the market has expected the latest commercial product was announced for 2019 out of Fujitsu. And we're still working on that. This is actually a wafer from that project that we're still working on. But we're really proud of where we are because we have reached some significant milestones, including 5 sigma performance at 1 million cycles, which, when it comes to not only inventing a new technology that works and you think that's great, you got to make it work to the gigabit scale. And all of those things have to be working. All those zeros and ones have to be clicking, or else you have defective chips. And you're never going to be cost competitive with DRAM. So we are still fighting that fight, and we're still excited about the technology and where it is. And I think lastly that, over the 20-year period that I'll say in terms of where we stand now is, and this is natural, and this is why the CHIPS Act exists and why we're very excited to be a part of MITRE, is when you get to a certain level of success in this business and as a startup, you start to get calls and start to get interest from overseas. And we're very proud to be partnered with many great Japanese companies. And the Japanese government has decided to focus on our carbon nanotube memory NRAM as the only memory selected for their national green data center project, where they looked at all the other memories out there and they said NRAM and carbon nanotube memory is the one that can achieve extreme energy reduction in data farms. And so we're going to put our research money behind that technology. That's great, and we're really excited and proud to be a part of it. But of course, the sticky part business-wise is we're a U.S. company. That's a Japanese national project with Japanese companies. So we're essentially a supporting role for a technology that we invented and that we have created. The fact that the CHIPS Act exists and the fact that we're a part of it and so vocal is because I think we have a very unique story. We can tell what happens when a startup that's VC funded sends $30 million to a specific fab and gets terrible wafers back, and you say, what do we do now? So those kind of things happen to startups in this business. And it's really important for the taxpayers to get what they invested in, to have companies like us that can kind of help MITRE and Commerce and NIST avoid those pitfalls as you guys make policy and execute. So that answers your question.
Yeah, that's sort of a great entree, because you touch on so many of the challenges that startups are facing, right? From the capital intensity to just the long periods and the high level of long periods of development, and then the high level of sort of perfection that you have to achieve to even be able to consider entering the market, right? And interesting, you also touched on sort of just the most recent sort of wave that's kind of coming over the industry, a focus on sustainability, both from a production point of view, but also from the consumer use and power consumption and everything else. It sounds like you just so many angles to attack here. But Raul, when you think about some of those wafers that came back, what was sort of the most challenging part about getting CNT based memory to work and to succeed at the level that you've been able to bring it to?
Yes, that was our biggest challenge. And I started Nantero in 2003, like a few years after it was founded. And at that time, when we were trying to engage with a fab, and they basically said, don't bring your dirty carbon nanotubes anywhere near us.
Contamination, right? Yeah, that's right. Yeah.
So that was our biggest challenge, to get the materials, to prove the fabs basically that our material, we can make the material that is has the right kind of purity that they expect and the right kind of uniformity, and it will not delaminate and cause problems to their multi-million dollar tools. So those are the kind of initial challenges we had to face with the fab. And that is basically any fab, when they want to introduce a new material, they'll do something called a contamination check. Which is basically run several wafers. First, show them the data that it has the right specs, and then run several wafers through the different processes to make sure there are no issues. And that is just the technical piece. But on the business side also, we have always kind of fighting this problem of access to the fabs, because if there is a strong demand for running regular chips, they would rather do that than try to install a development program, right?
Yeah.
So, and that challenge became very acute during the COVID, and we are still facing that challenge. And with the CHIPS Act funding, if we can get more fabs established in the US, that will be required to actually install development processes for developing new technologies. That will be really good.
So if I were to say just to outline the gauntlet, if you can get the technology to work, and then you can get the pile of money you need to get in, and then you can reassure them about contamination, and then you can also find a very precious sort of slot in their production schedule, then you might get a chance at sort of proving that you can operate, at full production or at full yield, right? Or
so we are at a stage where we are beyond trying to prove our technology works, because we have worked with many companies for several years, like Rob mentioned Fujitsu and several others we have worked with in the past. So we are kind of beyond that initial stage. Now we are at a stage where we have to run several wafers to basically show yield and things like that, which is actually tough, because then the fab has to give us enough time and enough wafer runs, which is what becomes a challenge.
Right.
And Scott, I'd like to add one thing to your list. When you said, so let me get this right, you guys have to do this, and this, and then if you find a tiny slot in their production schedule, you're missing one very important one, which is, oh, and by the way, the owner of that fab has a large market share in the technology you're trying to disrupt. So you're basically asking for a spot in their fab to make your technology because you want to compete with their products. I mean, and that is why we are in these meetings and have, asked we're not a large company, so we're asking a lot of our people doing real R&D work to, put on several hats and join these meetings. But it's really important, because at the end of the day, we know if these resources are spent and invested correctly, then you have companies like us that maybe, just maybe, the next Nantero doesn't have to be chemical materials engineer, designer of CMOS wafers, paying for the lost opportunity cost of a bunch of DRAM wafers to get ourselves in fab, all of these things that make our life extremely expensive. Even just licensing CAD software for chip design is very expensive, and we have to do all that if we want to be in this business. So anyway, that was an important one. I thought.
Yeah. So I'll pivot from that, Rob. Like, if let's say that you're able to meet the entire gauntlet, right? What does success of Nantero mean for just sort of the future of semiconductors, right? Like, how does that boil down for the consumer or for the product maker, if you will?
Yeah. So Nantero's business model, and this is what everyone, I would say 99%, or let's say 90%, but of people will look at what we're doing and they'll say the smartest business model is that of a licensing model, meaning we focus on creating the system of getting carbon nanotubes into fab, and we have that process buttoned up. We have the technology and the chemical engineering buttoned up, and we can go to any of these fabs or any of these big companies and say, here's the process, we will license it to you. And then they take it the next step and they pay for 10,000, 100,000 wafer runs to perfect the technology and get it to where it needs to be. And that was what Nantero's business model was forever. But what we found over the years is, because the licensing is very small in terms of the market share that you need to afford a bunch of these steps, you realize that the business deal you're fighting for at the end of the tunnel isn't going to pay for the costs that you had to go into it. And that's just because that's what's been established in the marketplace as the type of royalty that would go to someone who develops a process. And so we had to flip our business model and say, okay, we're going to have to push our first product into the market. It's got to be us. And so what that means is, now, instead of just creating the process, we're on the hook to figure out running 100,000 wafers of NRAM so that we can learn enough about it to perfect it and get it to productization level. And so, I don't know if at some point in our process, one of the big companies or, someone with much more bandwidth, if you will, than us will say, uh-oh, here they come. They finally got to this point. Now we got to start talking to them. That might be what happens. But I do know that in the licensing world, what will tend to happen is what the valley of death does to you, which is people see that it's going to cost you tons and tons of money to get to where you need to go, and they're just going to sit back and say, we can wait these guys out until they die, and then we can come in and pick up their IP for cheap. And if we want to dust it off the shelf someday, we can. But that's how they essentially can absorb us. That's one way. Or the way that Nantero has gone so far, anyway, without the CHIPS Act happening, is a foreign country gets excited about the technology and building an industry in their country, and that's when they can attract the talent and the technologies that come out of the United States' top research programs and was nursed by the top VC community in the world here in the United States. But then in that critical piece between VC funding and commercialization, that's when large state-backed dollars can persuade or can breathe life into a company or a technology just before it's ready for that last commercial step. And unfortunately, it just becomes a foreign technology, a foreign bedrock where the industry is now centered overseas as opposed to where it was invented. So we're still fighting, and we're still in that unique position, and we're very excited to submit our RFPs and to participate with MITRE to come up with what exactly would look best for helping Nantero stay a U.S. company and grow here.
Yeah, that's great. And I think one of the big focuses of the CHIPS Act and of the Semiconductor Alliance is to rebalance as much as we can in the semiconductor supply chain back over to the US, right? And to keep those critical technologies that are important for our economic security and our national security, to keep them based in the US. Great to see you guys, trying to hold on to that and keep it here despite everything else, all the challenges to sort of do that. If we think about sort of, we kind of like danced around and touched a little bit about the global nature of semiconductors. One thing that we sort of think about here a lot at MITRE Engenuity is that global nature, both of technology, but also of talent flow. And we're starting to talk more and more about workforce development and how that relates to the CHIPS Act. And Dr. Sen, I know like you earned your PhD in India at the, I think, the Indian Institute of Science. And then you did a postdoc in Japan at the Tokyo Metro University, I think, right?
Yeah.
And then you did another postdoc here in the US at UC Riverside. So all of this sort of before joining Nantero you're sort of the poster child here of the integrated global talent flow network, if you will. So, and we're really fortunate to have that you ended up here in the US. But how do you, when you think about your journey, how do we make sure that the US is sort of continuing to be a destination place where semiconductor talent or all the talent that sort of surrounds the semiconductor industry, whether it be everything from material science to computer science to math and physics, we continue to sort of be that destination that folks want to go to?
Yes. And I came to the US not just by chance, but because this is the place where there are opportunities for people like me. The best opportunities in the world still, I still believe it still exist in the United States. And especially for doing cutting edge technologies like what I was working on. My experience in India and Japan actually gave me that global outlook, which actually helps me to work with our Japanese partners and our global partners. So that is really a good background I have. But I've been in the US for more than 20 years. I'm a US citizen. And the kind of opportunities like a company like Nantero, I don't think will exist anywhere else in the world. And that is the attraction of US, and we have to see how we can keep that going, especially in semiconductor industry, which is unfortunately a lot of the processes are moving abroad, and if you stop manufacturing things here, you lose the edge over time.
Yeah.
So the fact that US government has realized that and is investing in the CHIPS Act, that is a really good sign. And we have to make sure that we can leverage that fully by thinking of actually, like you said, we want to do like a holistic development. The industry should develop, but also you need to have workforce development across various fields.
Yeah. From the ground up, or from almost every position, I think.
Yeah,
right?
From every position, and not just electrical engineers, because usually semiconductor industry gets dominated by electrical engineers, but we need material scientists like me, and you need chemists, you need process engineers, and you also need people who know business and things like that. Right? We need people with different skill sets all coming together.
And Rahul, that's a great point. I just want to add something real quick, which is, one of the challenges that most or every semiconductor company faces is when you look at, okay, federal subsidy dollars into an industry, how many jobs will it create? That is a tough equation for this industry because we're making teeny tiny little pieces, and you make them in small places and all that. So it's a challenge. However, the glimmer of hope, or the reason why I think that there needs to be a little more peeling of the onion, is because when you look at what we have created with a new material, the material side does create a lot of jobs. And it's large chemical companies are a huge sector here in the United States, as they are in Japan. And so we have, jobs on that end as well. So when you look at a CMOS fab, that's a certain part of the equation. But when you're talking about, and all the legislation and the law and MITRE, you guys are focusing on how do we get new materials. That is a whole separate bucket of jobs that will be created. And that is an important thing to look at. Then you can look at all of the different things that need to go into semiconductors, including, packaging, as we know, and you have all sorts of wonderful technologies, EDA tools, all that stuff. So there's a lot of jobs that are kind of under the surface. And Nantero, because we've had to be tooth to tail, we've had to do everything in the spectrum. We can't just focus on materials. We have to be materials and design and fabrication and testing and talking to the packaging folks to make sure that, so we've had to do all of it. And so we see that there's a cluster and an ecosystem that follows. And I do just want to circle back to one thing quickly, because I want to make sure, we are extremely excited about the opportunity for international cooperation. Clearly, Nantero is an internationally connected company with lots of great partners overseas. And in fact, we're extremely also excited that not only is the CHIPS Act here, but also there was an initiative announced by Secretary Raimondo and by Secretary Blinken to do an advanced semiconductor research initiative with Japan specifically. And so we're very excited about that, because ultimately we would love to continue working with our partners. And believe it or not, our partners are talking about, hey, we will gladly come and build plants in the United States for carbon nanotube supply chain production, just like we have in Japan. They will do that. And so I think the fact that the international approach and saying, we're going to take this money to attract the talent from overseas and the companies from overseas, so long as those dollars are in the US. Now I get to show up to the table with the Japanese funding that's available for us. Now I get to show up with my government who's backing some money, and we get to say, okay, now let's have a fair conversation. We're not trying to just say, oh, everything in the US. You don't want to talk like, no. I just want a fair negotiating position. And when you have a nation state backing companies and you have a much smaller company that's by itself, those negotiations don't look very pretty. And so that's why I'm very excited about using, and that's one way to take the 52 billion and make it look like 300 billion, because you're making the right investments.
So Nantero is based out of the Boston area. And what's the semiconductor scene like in Boston? You've been there for the entire time of the company. Would things have gone differently, or would, why not the Bay Area?
Well, the reason it started here, because it, as Rob explained, the technology came out of the Harvard Graduate School, and all our co-founders were from Harvard University. So I think that's the reason it started in Boston area. Boston area actually used to be a hub for high-tech semiconductor industry many years ago. It was the Route 128 area.
Yeah.
That kind of, there was DEC Computers and EMC and many big companies around this place. But that has kind of shifted to the Bay Area, and Bay Area was actually really the birthplace of the semiconductor industry as we all know it. There was some activity in the Boston area as well.
Silicon Valley, right? Like I got its name from that, but you're right. I think DEC was the first VC-backed company, or the first like VC as we kind of know it, right? And that was out of the Boston area. So it's got a long, rich history there.
Yeah, and Boston area right now is, as everybody knows, is a hub for biotech industry.
Yeah.
And that is actually somewhat of a challenge for us, because what we do here is we run our chemical processes here. So we do the material science and chemistry work in Boston. which means we need good chemical engineers, chemists, and to attract good people, we have to we are competing against the big biotech giants to get good chemists and chemical engineers, which becomes a challenge for us.
It's interesting because other startups I've talked to are competing with, say, FANGs, right? Are competing with like the Facebook, Amazon, Netflix, and Google, right? For talent, because they're heavy on software.
Yeah.
But you're actually competing with the pharma sort of for heavy on chemistry. Yeah. I know that's always a challenge as you're as a startup with more limited resources to attract talent. So it's interesting. And how do you go about sort of overcoming that or convincing folks to make the leap and be part of startup land and not go off to big corporate pharma?
Get them excited about the technology.
Yeah. We have to change the world.
I think, we do have a Sunnyvale, Silicon Valley office. And, so the way that our company is structured is as Rahul said, our Woburn facility is where our chemical engineering happens. And it could be a production facility if it needed to be. Right now, we have Japanese companies who can produce our solution and ship it to fab for fab stability. So we can use our facility and are using it as additional R&D. But that's the Boston site. The Sunnyvale site is our design and test center. So effectively, our wafers go from Woburn to fab, wherever that may be, and then they come back to Sunnyvale, where the team tests the product and makes changes and tweaks to the design. Was it the carbon nanotubes that were the issue this time? Was it a design problem? And that's what most, memory engineers will tell you is you need to run, what is it, Raul? 100,000 wafers before you really know a memory. So that's that, if you had to look at the numbers game or, if you're reading like Malcolm Gladwell's, outliers and stuff, the magic number for getting to a functioning wafer with memory, if that's 100,000, if that's the case, I don't have data on this, but if that's the case, Nantero has spun about 5,000 at this point. And we're a 20-year company that has had $300 million invested in the technology. About half of that was equity, and half of that was revenue that we made over the years. But that's where the math equation, that's where the CHIPS Act needs to come in. That's where the resources and the phablets, the phablets come in, so that we can get to that number. And what you'll see, as Rahul said so perfectly, he doesn't believe that an Nantero could exist in another country like it does here. And that's because of the amazing talent that's attracted to the country, the amazing research institutions that we have to kickstart these kind of technologies, and then the VC communities that will invest and take a risk. Now, what we just have to do is we got to put the guardrails around that last mile or that last 10 yards if you're talking the swimming pool, or the last mile if you're talking the Valley of Death, and get those technologies that have been fed by that system over and give them the resources they can get over the line. And once you do that, can you imagine if, when, as you mentioned, what would the world look like for, with carbon nanotube technology? We're energy efficient. Japan picked us up because we save 30% energy in a server. And that would plus up to a data center. So you're talking about green data centers reducing, the power consumption by 30%. And they suck a lot of power. So that's one thing. The other thing is you could make the new supply chain from the ground up, meaning all the supply chain that services current CMOS process, you can now start it here in the US and grow it. So there's just a lot of and we're also not asking for nearly as much money as the big companies are and who have big plans. And that's great. And we need those guys. At the end of the day, we need the big companies to be good at what they do and to invest in these big facilities. And we're so excited that there's been a lot of great projects announced. But we're asking for a very small amount of resources from this CHIPS Act so that we can potentially be the biggest gain. So if you invest a lot into the big guys and a little into the little guys, you might find that the little guys produce the most return for taxpayers. And so we're certainly on board for that, for pushing that narrative, because we know it's true.
Yeah, certainly a leapfrog technology, as they say, right? So kind of just bound us right over where we are into a new area in terms of power consumption, and also in terms of performance and everything else you really want around new technology. So that's fantastic. Well, so Rob, if there was sort of, if you had a message for other innovators that are trying to bring something like this to the market in semiconductors, what would your message be right now?
Wow, man, that's a tough one. It wouldn't be don't do it, I promise. I would say this. I would say, look, you have a lot of choices, and if you're gifted enough to be smart enough to be interested in this technology field, I would say this: there couldn't be a better time, especially if you're in the U.S., to be focused on this industry. And I tell my staff the same thing. I'm saying you guys have been battling for a long time, but for the first time ever, a Congress and a president and a Commerce Department and lots of great folks at MITRE and all over the place are saying, hey, we hear you. We hear that it's hard. We hear that it's near impossible to make it work. And this is something the country's been struggling with. So we've got your back. Here are the resources. Now let's talk about how we get it done. You now, if you're getting into this and you want to innovate, and you're looking at either a job or you're looking to start a technology, you have a better chance of success now than you ever have. And also, when you look at the cool, I mean, there is, of course, that moral dilemma when it comes to, do we really want, machines that can think for themselves whenever we talk about AI? That's for sure some dilemma
set that aside.
To think about. But at the end of the day, it will be developed. It will be, the technology will come. And the question is, have we done it here? And have you materially participated in it? And so, so I would say you have a better chance of success now than you ever have. And you have, a country that hears you, and you have a lot of facilities being built, and you have a lot of really cool technology to come that needs lots of innovation. So it should be a fun thing. The business side of it is the business side of it, and that's a challenge. But the innovation side of it is some of the cool stuff in the world. Who knew that I could literally call Rahul's university right now and just say hi, in India. It's amazing. It's just amazing how interconnected we are. And it's all because of the magic and the materials and the amazing science behind this stuff. And it's exciting.
This is kind of a Sputnik moment for America, right? Like, in the sense that, if you remember, we were kind of in a mild space race with the Russians before Sputnik. And then suddenly we looked up and there was this satellite going over our heads that was somebody else. And we realized the sort of longer term strategic and technical implications of what that meant. And that got us to all rally around the Apollo project. And then suddenly, being an astronaut was a possibility, and being a systems engineer on rockets going to the moon was a possibility. And it really opened up a lot for young engineers and for anybody who might be interested in that kind of space, or people that would just sort of stumble on it and be interested in that. So we're kind of seeing the same thing now, in the sense that our manufacturing capabilities are down to 10% maybe of the global supply, and adversarial countries, theirs are rising up to 24-25%, and 25% in Taiwan are vulnerable. So it's great to see kind of a unification across the aisles, and a lot of sort of focus on this, I guess, and interest in it.
Exactly. In a country that has a very robust tech industry, but like you said, it's the FANGs, right? A lot of people think about coding, and a lot of people think about the software side and the platforms and the apps and all that. But really, the science that underlies it is what creates connectivity. I mean, it creates better safety. It creates learning in classrooms. When you have a biological pandemic and you send kids home, they now can learn and continue to be connected with their classmates and their teachers through devices that we've created. When you look at being able to have this interview without burning tons of JP5 jet fuel to get us all together in the same room to talk into a microphone. These are the things that the magic and the miracles of these little tiny devices can do. And we still have a lot to uncover. We still have a lot to explore. And hey, nanotubes are extremely small. So as you get into those super, super small node sizes, there's going to be a lot of interest in nanotubes. And Nantero will be right there to share what we've done with the world and add to this progress that this industry has made.
Oh, that's fantastic. That's exciting. So, Rahul, can you tell me, just for the layman or for the rest of us, what other kind of applications do you see this kind of technology going? Like, how else can carbon nanotubes be used, and what other changes can they make outside of, memory sounds like a fascinating sort of application, but what else are you thinking about doing once you master that?
Just staying within the electronics or semiconductor space, carbon nanotubes actually, they have unique electronic properties. So they can be metallic or semiconducting.
Yeah.
Depending on how the carbon atoms are rolled up. And for the memory application, we don't need to separate them out. They can be a mix because we are using an electromechanical property of the tubes. But if we can separate the semiconducting carbon nanotubes out, then you can make transistors out of those. And those can be really very high-speed transistors because they are ballistic. And that is something that many companies have been looking at, and also something Nantero is interested in, because our materials technology platform that we have developed for memory can be applied with, of course, there's some development work that still needs to be done, but can be applied to the transistors, because we are the only company that has introduced nanotubes in the fab. So that is the two things. The other thing is that if you just take the metallic nanotubes out now, okay, semiconductor nanotubes used for field effect transistors. Now take the metallic nanotubes. They are again they have very high current carrying capacity. Mm-hmm. So they can be used for interconnects, like replacing copper. And things like that. So
packaging play eventually.
Packaging,
memory, and then you go to processing, and then you go to packaging, and then
they also nanotubes also have very high thermal conductivity, so they can be used for thermal management at the chip level. So those are the kind of semiconductor space. Those are the applications I can think of. Now, thinking a little bit further out, nanotubes, because they are just made of carbon, they are very flexible. Inherently flexible, so they can be used in flexible electronics, where you can make your memory and your transistor, everything on flexible substrates, and you can use them for flexible electronics. Going beyond there are other applications also people are looking at are sensors, because nanotubes are very sensitive. The electronic properties of nanotubes are very sensitive to what kind of gases or molecules are absorbed on them, so they can be very, very sensitive sensors. Mm-hmm. So people are looking into sensors. People are also looking into sensors. You can have chemical sensors, or you can have like piezo sensors or mechanical sensors. Different kinds of sensors you can make with nanotubes. Moving out of the electronics field, carbon nanotubes today are being used in lithium-ion batteries to enhance the conductivity of the cathode materials. The cathode materials in lithium-ion batteries are typically oxides that are good for intercalating lithium, but not very good for transporting the electrons. Mm-hmm. So people traditionally added carbon black as an additive to improve the conductivity of those, but now people are finding that if you add carbon nanotubes, you can get better performance. And a lot of companies are investing heavily in carbon nanotube for lithium-ion battery applications.
So there are so many applications there. It's like we'll have to really open up the supply chain for carbon nanotubes.
Yeah. This is just, I can go on and on, but I think I'll stop here.
No, and you bring up a great point, Rahul, that I think I also like to acknowledge. MITRE being a great arbiter of these breakthrough challenges and trying to put forth some of these ideas, for example, that Rahul just said, hey, carbon nanotubes can do these things. And, you guys have identified the breakthrough challenges as a way to lift up technologies. And I would like to just say that, I've been very proud to be a part of those discussions. We've been very proud to be a part of those discussions. And we also would like to thank, the other companies that are involved. I have seen that my team is treated with a lot of respect, and when it comes to large dollars and how to spend them, and you have professionals from large companies, you might expect that there's going to be a lot of pushback and whatnot. But so far, I just think the industry has been very responsible and very friendly and working to actually find the worthwhile technologies that can be pushed forward and are deserving of a chance for some of that money to help get them lifted off the ground. And so I just wanted to say I've been very proud to be a part of this industry in the U.S. And to see us all coming together under groups like MITRE to talk about how we can best guide policy and suggest things to the government. So I just wanted to make sure that we said that.
It's a great endorsement for the Semiconductor Alliance and for all the work my colleagues are doing around that space. So thanks for that.
Yeah, thanks. Thank you for all your hard work, guys. Really, we appreciate it. Thank you for being the referees in the room, and and I think everybody's playing nice.
Rob, Rahul, thank you so much for joining me. This has been a great conversation about semiconductors in America and everything sort of in between. So, want to appreciate you for all that you're doing out there with Nantero and all the things you're doing with the Semiconductor Alliance. And I can't wait to talk to you all again soon.
Thank you
very
John.
much.
Yeah.
Thanks for all your hard work, and thanks for having us. We're proud to be here.
Pleasure.